In today's lesson, we are diving into something really exciting called redox reactions. But before we start this topic, I want you to take a few moments to think about this. Have you ever seen a rust forming on a metal or a candle burning? Well, both of these are examples of what? Redox reactions. So let us find out why. So what exactly is redox reaction? So redox stands for reduction oxidation reaction. It is simply a reaction where reduction and oxidation reactions occur simultaneously, meaning both reduction and oxidation reactions occur or happen at the same time. So this type of reaction is called redox reaction. So in other words, a redox reaction is one in which electrons are transferred from one atom to another. So if there is transfer of electron from one atom into another, this type of reaction is called redox reaction. So let us compare and contrast oxidation and reduction reactions. So oxidation is referred to as loss of electrons. So when electrons are lost, the reaction is said to be oxidation reaction. Reduction, on the other hand, is the gain of electrons. So when a substance gains electrons, the reaction, the half reaction, is called reduction reaction. So let us consider this example. So oxidation half reaction is written in this way. And remember, because electrons are lost, the electrons are written on the product side. Whereas for a reduction reaction, because electrons are gained, the electrons are written on the reactant side. So therefore, this example is an example of reduction reaction. So let us use analogy. Okay? So think of electrons as many being exchanged between friends. Okay? So when one friend gives many away, he or she is losing electrons, right? So this kind of reaction is called oxidation. On the other hand, the other friend receives many. So this type of reaction is called reduction reaction. Okay, another definition of oxidation and reduction. So oxidation and reduction can be defined in terms of what? Oxygen. So oxidation is defined as gain of oxygen, whereas reduction is defined as loss of oxygen. So let us consider this example. Acetaldehyde has one oxygen in its structure, whereas acetic acid has two oxygen atoms in its structure. So what has changed is the number of oxygen atoms. The number of oxygen atoms has increased or gained, right? Therefore, we say that this carbon has been oxidized because it has gained oxygen. Let's see another definition of oxidation and reduction. Oxidation can also be defined in terms of hydrogen. Therefore, oxidation is defined as the loss of hydrogen, whereas reduction is defined as gain of hydrogen. Consider this acetaldehyde. How many hydrogen atoms does it have in its structure? 4, right? Let's come to this structure, which is ethanol. Ethanol has how many hydrogen atoms in its structure? It has 6. So what has changed is the number of what? The number of hydrogen atoms has been changed, right? So this carbon has increased in the number of hydrogen atoms. Therefore, we say that this carbon has been what? Because it has gained hydrogen atoms, it has been reduced because it has gained hydrogen atoms. So this is another definition of oxidation and reduction. So the fourth definition is we can differentiate these two reactions based on the oxidation number. So oxidation is defined as the increase in oxidation number, whereas reduction is decrease in what? In oxidation number. Let us assign the oxidation states of each atom. So iron, because it is in uncombined state, its oxidation state is 0. And remember, phosphate has a charge of -2, therefore copper has a charge of 2, oxygen has a charge of -2, and sulfur has a charge of +6. What about the charge of iron here? It is +2, +6, -2, and the oxidation state of copper is 0. Let us consider iron. Iron has changed from oxidation number 0 to +2, right? So iron has been what? Oxidized, because its oxidation has increased from 0 to +2. Whereas copper has decreased its oxidation state from +2 to 0. Therefore, we say that copper +2 has been reduced because its oxidation number has decreased from +2 to 0. Now let us see the key players in the redox reaction, and these are the agents. So an oxidizing agent is a substance which helps to oxidize another substance by accepting electrons from it, and itself gets what? Reduced in the process. So in other words, an oxidizing agent is the one that helps others get what? Oxidized by accepting electrons. Because it gains electrons, the substance itself gets what? Reduced. On the other hand, reducing agent is simply a substance which helps to reduce another species by donating electrons from it, and itself gets what? Oxidized in the process. In other words, a reducing agent is the one that helps what? Others get reduced by donating electrons. Since it loses electrons, the substance itself gets what? Oxidized. So let us compare and contrast these two agents. So reducing agents loses what? Electron. Whereas oxidizing agent gains what? Electrons. Reducing agent causes reduction, whereas oxidizing agent causes what? Oxidation. And remember, reducing agent undergoes what kind of reaction? Oxidation reaction, whereas oxidizing agent undergoes reduction reaction. So reducing agents become more positive because they undergo oxidation reaction, whereas oxidizing agents become more negative because they undergo reduction reaction. So the first example. So the question says, identify the species being oxidized, reducing, and oxidizing agents in the following balanced redox reactions. So we have this reaction. Now let us see how to assign which species is being oxidized, reduced, and the reducing agent and oxidizing agent in this example. So the first step is we have to assign oxidation number to each atom, right? So I'm going to start with this hydrogen. So hydrogen, when it is bonded with carbon, it has +1, right? So what will be the oxidation state of carbon? So I'm going to assign it X. So remember, because this is a neutral molecule, 2X, so I have 2 subscript here, plus 4 equals 0, 2X is equal to minus 4 over 2 over 2, therefore X is minus 2. So the oxidation state of carbon in this example is minus 2. So it's minus 2. What is the oxidation state of hydrogen? 0, right? And the oxidation state of hydrogen in ethane is +1, and oxidation state of carbon is -3. So consider this, going from 0 to +1. So which one has been oxidized? Hydrogen, right? Hydrogen with oxidation state 0. So you have to always write those on the right hand side. So hydrogen has been oxidized. Which species has been reduced? So going from -2 to -3. So carbon with oxidation number -2 has been what? Has been reduced. Now let us see which one is the oxidizing agent and the reducing agent. Okay, so now let us identify which species is the oxidizing agent. So remember, oxidizing agent is a substance that helps another substance to get what? Oxidized. But itself gets what? Reduced, right? So carbon has been reduced, therefore, so the oxidizing agent is C2H4. You have to write the substance as a whole. And the reducing agent is a substance that helps the other substance to get reduced, but itself gets what? Oxidized, right? So the reducing agent is hydrogen. So in this way, you can identify which substance gets oxidized, reduced, and which one is the reducing agent and oxidizing agent. Let's try another one. Now the first step is you have to assign the oxidation number. So we'll start from oxygen. Remember, the oxidation state of oxygen is -2 in most cases. Therefore, the oxidation state of copper is +2, and that of hydrogen is 0. And copper in uncombined state has 0 oxidation number. Oxygen has -2, hydrogen has +1, right? So hydrogen going from 0 to +1, going from 0 to +1, it is an increase in oxidation number. Therefore, hydrogen has been what? Has been oxidized. And which species has been reduced? Copper going from +2 to 0. Therefore, copper +2 has been what? Reduced. So remember, you have to write those substances or species on the reactant side on it. And now let us identify which species has been acting as oxidizing agent and reducing agent. So remember the definition of oxidizing agent. It helps another substance to get what? Oxidized, but itself gets what? Reduced. Therefore, copper +2 has been reduced. Therefore, the oxidizing agent is copper 2 oxide. And the reducing agent, on the other hand, so reducing agent is a substance that helps another substance to get what? Reduced, but itself gets what? Oxidized in the process. Therefore, hydrogen has been oxidized. Therefore, H2 is acting as an oxidizing agent. Let's try this example. Remember to assign an oxidation state for each atom. So the oxidation state of sulfur is -2, and that of hydrogen is +1. What will be the oxidation state of nitrogen? Let's assign this X, and the oxidation state of oxygen is -2. Therefore, X minus 6 equals, because it has a charge of -1, equals -1. Therefore, X is equal to +5. So the oxidation state of nitrogen in nitrate is +5. So this is +5, and this oxygen has -5. What is the oxidation state of sulfur in elemental form? 0, right? And the oxidation state of oxygen is -2, and that of nitrogen is +2, because the sum of the oxidation states of all the atoms in a neutral compound should sum up to what? 0. Therefore, the oxidation state of nitrogen is +2, and hydrogen has +1, oxygen has -2. So let us see which species has been oxidized and reduced. So nitrogen going from +5 to +2. Its oxidation number has decreased, right? So nitrogen +5 has been reduced, whereas S-2 going from -2 to 0 is an increase in oxidation number. Therefore, sulfur -2 has been oxidized. So let us write it here. Oxidized species will be what? S2 minus. Reduced species will be what? N+5. And then the oxidizing agent is the one that helps what? The other substance to get oxidized, but itself gets reduced, is nitrate. and the reducing agent is hydrogen sulfide. Example number 4. So, as always, let us assign the oxidation number of each element to figure out which species has been reduced, oxidized, and which one is acting as oxidizing agent and reducing agent, and so on. Therefore, what is the oxidation state of oxygen in manganese 4? It's -2. Therefore, the oxidation state of manganese is +4. Hydrogen +1, bromine -1. So bromine is -1. So for the oxidation state of manganese is +2. The oxidation state of bromine is 0, and that of hydrogen is +1, and that of oxygen is -2. Therefore, if you consider, so bromine going from -1 to 0, its oxidation number has increased, right? Therefore, it has been what? Oxidized. Manganese going from +4 to +2, its oxidation number has decreased, therefore it has been reduced. So therefore the oxidized species is bromine with oxidation number -1, and the species which has been reduced is manganese +4. Oxidizing agent is the one that has been what? The one that helps other substance to get oxidized, but itself gets reduced, right? So manganese 4 oxide is the oxidizing agent, and the reducing agent is a substance which helps other substance to get reduced, but itself gets what? Oxidized, and that is hydrogen bromide. Alright, now let us see factors that affect the strength of oxidizing and reducing agents. So there are 2 factors. The first one is electronegativity. Remember, it refers to how strongly an atom attracts electrons towards itself, right? Therefore, elements or atoms with higher electronegativity values tend to be what? Good oxidizing agents. On the other hand, elements with low electronegativity values tend to be what? Good reducing agents, because they favor losing an electron to become a more stable atom. So the second factor is oxidation states. Elements with higher oxidation states act as oxidizing agents, good oxidizing agents, because they really want to gain their electrons back. On the other hand, elements with lower oxidation states tend to or act as a good reducing agents because they want to lose their electrons. So remember, not every reaction is a redox reaction. So non-redox reactions are reactions where the oxidation states of the elements remain unchanged in the reactants and products. So therefore, reaction is in which neither oxidation nor reduction takes place. or no species either gains or loses electrons is called non-redox reaction. Both double displacement and acid-base reactions are considered as good examples of non-redox reaction. So let us see why these examples are considered as non-redox reaction. So to help you figure out which reactions are redox reactions and which are not redox reactions, you have to assign oxidation state to each element and see if there is change in oxidation state or not. So let us begin with the first one. So what is oxidation state of sodium? It's always +1, right? And sulfur +6, -2, +2, -1, +2, +6, -2, +1, -1. So as you can see, there is no change in oxidation state in the reactants and products. Therefore, this type of reaction is called non-redox reaction. Similarly, calcium carbonate. So what is oxidation state of calcium? +2. And what is oxidation state of oxygen? It is -2. Therefore, what is oxidation state of carbon? It is +4. +2, -2. -2, +4. Therefore, there is no what? Change in oxidation state in the reactants and products. If there is no change in the oxidation state of the reactant and product, this is also an example of what? Non-redox reaction. Similarly, what is oxidation state of potassium? +1, oxygen -2, hydrogen +1, +1, +5, -2, +1, +5, -2, +1, -2. There is no change in oxidation state. Therefore, this is also another example of non-redox reaction. So this is how you identify which reaction is redox reaction and which is not. So to sum up, remember, oxidation is always what? Loss of electron, and reduction is gain of electrons. So oil rig. So O represents oxidation. Oxidation is loss of electron, and R represents reduction, which is gain of electrons. So this can help you to remember the definition of oxidation and reduction. And the other point that you have to remember is the difference between oxidizing agents and reducing agents. Remember, oxidizing agents, we defined it in terms of oxidation state. So its oxidation state decreases, and for reducing agents have higher oxidation state. In terms of number of electrons, oxidizing agents gain electrons, whereas reducing agents lose electrons. And the substance is being what? In oxidizing agents, the substance is being reduced, whereas in reducing agents, the substance itself is oxidized. But it helps the other substance to get what? Reduced. Alright, now it's your turn, and try these practice questions and show your brilliance by dropping your answers on the comment section below. That's all I have. See you in the next session.